if fx plus fy is equal to cx square plus 3 multiplied by y to the power n for all real numbers xy, what is the value of f2? And we are given 5 options and we have to pick the correct answer. This is actually an old problem dating back to my high school days. I remember this problem being asked in one of our math quizzes, and nearly half of the class could not get the correct answer to this problem. The reason I picked this problem is I think it will help clarify some important concepts on functions, which is a topic included in high school math as well as various standardized tests. So how do we go about solving this problem? We start by substituting x equal to 0, y equal to 0. We know that the function is defined for all real numbers x and y, and since 0 is a real number, we can very well do the substitution. It's perfectly valid. And when we do that, we have on the left hand side f0 plus f0, so that's 2 times f0, and on the right hand side we have 0. So we have 2 times f0 is equal to 0, from which it's simple to obtain that f0 will be equal to 0. Now the second substitution that we do is x equal to 0. And when we do that, we obtain f0 plus fy is equal to 3 multiplied by y to the power n. And since f0 is equal to 0, we basically have fy is equal to 3y to the power n. And since this is a function, we can very well replace y by x. So we have fx is equal to 3 multiplied by x to the power n. So what's the next step? For the next step, we substitute y equal to 0, and this time we end up with fx plus f0 is equal to cx square. And again, f0 is equal to 0, so we have fx is equal to cx square. Now, if we put these two together, so we basically end up with fx is equal to cx square equal to 3x to the power n. So from this, we have this relationship, cx square is equal to 3x to the power n. Now, what do we do from here on? Well, one thing that we can do is really treat this like an equation and get a value for x, which you can do by manipulating the exponents, basically treating this as an exponents equation, and we end up with x is equal to c by 3 whole to the power 1 divided by n minus 2. And the question is this the correct approach? For one thing, this relationship that we have, it's not an equation, because an equation holds true only for certain values of the variable. What we have here from functions essentially is an identity, and an identity should hold true for all permissible values of x that are allowed on the domain of the function. And in this case, the function has been defined for all real numbers. So this identity should hold true for pretty much any real value of x. So from this identity, if we substitute x equal to 1, which is perfectly legal and permissible for this function, right? So we have c is equal to 3. So we obtain the value of c by just substituting x is equal to 1. And as a next step, we can write this. Since we obtain the value of c is equal to 3, so we can write 3x squared is equal to 3 x to the power n. And basically we have x squared is equal to x to the power n. Once again, this is an identity, so for this to hold true, n must be equal to 2. So now we have the value of c equal to 3 and the value of n equal to 2, and we know our function is basically cx square or 3x to the power n, however way you want to put it. We basically end up with fx equal to 3x square. And if we simply substitute x equal to 2, which is what the question asked for, we have basically f2 is equal to 3 multiplied by 2 square, and this gives us a value of 12. So the correct answer for this case will be the option D, 12.